Alright, so we're going to start solving systems of equations, and that's this note sheet. Oh my gosh. Okay. Alright, so this set is solving systems of equations by graphing. This is the first page of your note set. These are questions for you to answer. You've previously learned this information, so I'm going to skip this page. The essential question is, how can you solve a system of linear equations? And we hope to answer that with these examples. All right, so we're going to start here with work with a partner. Your family opens a bed and breakfast. They spend $600 preparing a bedroom to rent. The cost to your family for food and utilities is $15 per night. They charge $75 per night to rent the bedroom. Write an equation that represents the cost. So with the person who wrote this decided the cost would be represented by the letter C in dollars, and the charge was $15 per night times the number of nights, which we're representing with X, and then an additional $600 because they had to spend $600 preparing a bedroom. Okay. Then for revenue is your income, so revenue is also in dollars. $75 per night, because that's what they're charging per night to rent the bedroom, times the number of nights. So, and that's a straight up revenue. So this is the money that's coming in, and then A was the money that's going out. Okay. So when we have a set of two or more linear equations, it's called a system of linear equations. So write the system of linear equations for this problem. So based on what they've written out here, our two equations would be C equals 15x plus 600, and then R equals 75x. Now, because this is about money, we're going to replace the C and the R and let them both be represented by the letter Y. So we're going to have two equations. Y equals 15x plus 600, and Y equals 75x, okay? Because this is our dollars. Okay. So also working with your partner, use the cost and revenue equations from Exploration 1 to determine how many nights your family needs to rent the bedroom before recovering the cost of preparing the bedroom. This is known as the break-even point, where costs and revenue are equal. Okay, so cost in dollars, this first is going to be, right, we had 15x plus 600. So each time, that's what we're going to be doing for this line. We're going to multiply 15 times this x value and add 600. Okay, so let me erase that because it's going to get messy really fast. So 15x, 15 times 0 plus 600 is 600. Okay. 15 times 1 is 15 plus 600 would be 615. Okay. And then 15 times 2 is 30, so that would be 630. So hopefully you can see we're just increasing by 15 each time. We just keep adding that 15. Okay, for our dollars, right, that was our 75x, so we're just going to multiply 75 times 0, so 0 nights is $0. 1 times 75 is 75. 2 times 75 is 150. 3 times 75 is 225. And basically, again, we're increasing by 75, so that would be 300, 375, 450, 525, 600, 675, and 750, finally 825. Okay. So we copied and completed the table. Now then, how many nights does your family need to rent the bedroom before breaking even? Okay, so where do they break even? Well, right here at 10 nights, they spent $750 and they have received $750. So 10 nights, the family breaks even. And we'll just put that $750. That's the break even. Okay. All right. So in the same coordinate plane, graph the cost equation, the revenue equation from exploration 1. Okay, I want you to do this on your calculator. Okay, so we're going to go over to our calculator now. Okay, so now we go to our calculator and we want to graph it. So we're going to choose B to graph, and our first equation was 15x plus 600. Okay. No, it doesn't show up on the screen, and well, that's because 15x plus 600 means our y-intercept is at 600. That's going to be way off our screen, right? So we could go to our window, and we could reset our windows, right? And our minimum doesn't really need to be at -10 because we're talking about money. So we started at 0, right? So we're just gonna set our x minimum at 0, and our x max, well, on our table, our maximum x value was 11. So I'm going to put 11 down. Okay, and we're just going to let it decide, the calculator decide the scaling. Okay, and the same thing, the y minimum. Well, our minimum y was 75, I believe, but we'll go ahead and do 0. And then our maximum y was 825, I believe. So we'll put 825 in. And so now we can see a little bit more of the line. Okay, so now we need to graph the second line. So we hit tab, type 75x. Okay, and now we can clearly see the two lines, and they have a point of intersection. Okay, so this is where the graphing, solving systems by graphing comes into play, which was our lesson for today. If we'll do menu, and then we're going to analyze the graph, we're going to find out where do these two lines intersect. Okay, so we're going to come over here to the left and hit enter. Then we come to the right of the intersection point and hit enter. And you see it's showing us our point is 10,750, which is what we also found from our table. Okay. Okay, so we graphed the two, find the point of intersection, and that point was 10,750, and this is our break-even point. Okay, and it's the same point. It's the same point because it's the point that's in common to both the table and to the graph. I guess we should say both lines, really. All right, so tell whether the ordered pair is a solution of the system of linear equations. All right, so to tell if an ordered pair is a solution to a single equation, you just substitute it in for the x and the y and see if you get a true statement. So when it's a system, you substitute 2 and 5 in for x and y here and in the second equation. So we would have 2 plus 5 equals 7, which means 7 equals 7, and that is true. Then we'd say 2 times 2 minus 3 times 5. Is that equal to negative 11? Let's see, we have 4 minus 15, and that's negative 11 equals negative 11. So 2, 5 is a solution. To the system. Okay, same thing here, negative 2, 0. So there's our x value, our y value. So 0 equals negative 2 times negative 2 minus 4. Just substituting in negative 2 and 0 for y and x. Okay, so 0 equals 4 minus 4. 0 equals 0. That's true. Okay, let's try the second one. 0 equals negative 2 plus 4. So 0 equals 2. Well, that's not true. So that means that negative 2, 0 is not a solution to the system. Okay. So here, just some instructions, what we've already done. Graph each equation in the same coordinate plane. Estimate the point of intersection. If you're using your calculator, you're not estimating. But sometimes when you're graphing on paper, you'll have to. Check the point from step 2 by substituting for x and y in each equation of the original system. Okay, so once if you're estimating, you're definitely going to want to substitute back in to see if you got the right point. Okay, so solve this system by graphing. So y equals negative 2x plus 5 means we're going to go to positive 5 on the y-axis, and we're going to go down 2 and to the right 1 to follow our slope. Okay, and then we're going to draw our line through it. Let's see if I can draw one today. Okay, not too bad today. Okay, now equation 2, we'd start at negative 1. We have a positive 4 slope, so 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay. Line it through there. Okay. And right here seems to be our point of intersection, which is the point positive 1, positive 3. So now we'll try positive 1, positive 3 into our equations. So does 3 equal negative 2 times 1 plus 5? 3 equals negative 2 plus 5, so 3 equals 3. Yep, that works. Okay, and then 3 equals 4 times 1 minus 1. 3 equals 4 minus 1. 3 equals 3. That's also true. So 1, 3 is our solution. Okay, a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same prices, the contractor buys 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. Okay, so we're looking for what is the x and what is the y value. So we know in situation number 1, right, that we had 30 bundles of shingles, we'll call those S, and we had 4 rolls, we'll call that R, of paper, and that equaled $1,040. Okay. And then we had 8 bundles of shingles plus just 8 bundles of shingles for $256. Okay. So if we want to write this as an equation, we'd have to have x and y, so we could change that to 30x plus 4y equals 1,040. And S was, I'm going to say, this was our SRR, so this would be 8x equals 256. Okay. All right, so if we're going to graph this, we need to solve for y. And then this one doesn't have a y, so we'll just solve for x. So we divide that by 8, and that tells us that x equals, see, 8 goes into 25 3 times, so 32 times. So that is telling us that if we counted over, well, no matter what, x is going to be 32, right? Okay, so knowing that, we can also solve here. We'd have 30x plus 4y equals 1,040. So 4y equals negative 30x plus 1,040. Divide everything by 4. And we know that y equals negative, let's see, 4 goes into 37.5 times. And then 4 goes into 1,040, 260 times. Okay, so if we're graphing, x equals 32, we just count over on the x-axis to 32. We're going to have to kind of estimate that. I'm going to come back to that one. Let's try this. The 260, let's see, 20, 40, 60, 80, 1, 20, 40, 60, 80, 2, not enough. Maybe 40s, 40, 80, 120, 160, 200, 240, 280. Yeah, that gives us enough. And then so 260 would be about here. And then we're going down by 7.5 each time. Let's see. So we want to kind of represent 32. Kind of just estimating here, aren't we? What if we counted by 10? Yeah, we can count by tens. So 32 would be about here. Okay, so my one line is just the vertical line, x equals 32. Right, that's one line. And then we'll be decreasing this way by 7.5. So at 10, our x equals 32 line. And then this would be 260, and we're decreasing by 7.5. So at 10, that would be 75. Okay, so that's 20, and then 40 makes 60, and then 75 would be about there. This is where the estimating comes in. Okay, and then if we draw our line there between our 2 points, get it kind of lined up through there, and we just keep extending until we get through. Okay, so this appears to be our point of intersection. Okay. And now, that's great. It looks like it's between around 40, maybe, but we did a lot of estimating, so I'm not really satisfied with this as a graphing method, so I'm going to show you something else we can do. Okay, what we can do is, since we know that x has to be 32, right, and that was our s value back up right here, x had to be 32, so we can replace x with 32 and figure out what y would be there. Okay. So 30 times 32 is 960. And we subtract the 960. So we get that 4y equals 80. Divide by the 4. And it turns out our estimating was quite a bit off because it's only at 20. So this point should have been down here, right? Because it was at 32.20 that we actually have our intersection of our two lines. Okay, so that, to answer the question, that means that shingles are $32 per bundle. And roofing paper is $20 per roll. And that was the question they asked.